Hello everyone, this is Jamie from Team 16. Today I wanted to discuss with you our project for EEE488 Senior Design. We will be working with the U.S. Department of Energy for the first inaugural Solar District Cup. That means we will be designing a solar collection for Ball State University in Muncie, Indiana. Ball State would like to achieve climate neutrality by 2030, and our hope is that our senior design project can be a stepping stone in helping them do that. Our final package should include a conceptual system design, a distribution system impact, a financial analysis, as well as a development plan. Some notable dates we have coming up are on the 21st of November, we have our deadline for receipt of progress. And on the 12th of December, they will be announcing the finalist teams. Moving on to my part of the project, the conceptual system design. We have been given about 29 acres located near BSU apartments for the ground mount and 18 different buildings on campus for the building mount. Now, we have elected to omit 2 of these buildings. Those include the parking garage as well as the glass installation on the architecture building. We have chosen to do this mostly because of cost and also because of time. We might add them later, but as for right now, we'll be leaving them out. Here you can see the ground mounted installation. Now, this is just a very basic file. I will go back in and add some squares to show you where everything will physically be located. But for right now, I just wanted to show you the actual site. And here is the building mount site. You can see right there in the middle is the parking garage we will not be building on top of. We have a couple cool programs at our disposal, one of which is Google Sunroof. We elected to show you the Robert Bell building, and here you can see Google Sunroof tells us that we have about 1,400 hours of usable sunlight and 29,000 square feet available for solar panels. It gives us some breakdown of savings and kilowatt hours. It's really great. All you have to do is enter the address and Google will spit all of this out to you. Here you can see the actual building itself and where they think all of the panels will be. That is shown there in orange and yellow. The next and most important software that we are using is Aurora. Here you can see just a screenshot of the same building inside Aurora, but it's very different because it will show you actual individual panels as well as them all strung together. It shows you the inverters. Now, these panels are actually panels that we chose, so a certain manufacturer and a specific panel that they offer. This is something that Google Sunroof does not allow you to do. So Aurora, just by nature, will be much more precise than Google Sunroof. We really enjoy using this, but we had a significant delay when it came to getting the rights for the software. So we just now got access to this program, and we will have more built in there within the next few weeks.
Hello, my name is Trent Molesworth, and I am part of the Solar District Cup design team, and I've been put in charge of the distribution impact analysis. And the distribution impact analysis consists of 2 parts. The first is a descriptive approach to the power flow model. The second part is a power flow model designed in a software called OpenDSS. And the description of the power flow model has 4 parts. The first part is we need to determine the irradiance profile for our section of Ball State University. The irradiance is the rate at which the solar energy falls onto the surface of the earth. And using the irradiance profile, we'll be able to determine where the best place to put solar panels. And as you can see in the picture I've pasted on this slide, it's one of the buildings in our area. We can see the irradiance profile across the roof of that building. The second part of the power flow model is the load profile. And the load profile is going to show us the connected buildings and help us observe how much load each building is using. And after we add our solar, it'll be important to take note of that and see how much it's changed. And another part of the description of the power flow model is that we need to make sure our solar systems are in accordance with all the utility codes of Muncie and Indiana. That is just extremely critical, because if we don't, then obviously our solar system will not be able to put in place and we won't be able to construct it. And the last part is we need to make sure our control settings are put in place. We need to make sure all our regulators are in the right place and are functioning properly, so we can have a successful solar design. And because of the description of the power flow model, we can now turn to showing the power flow model in the OpenDSS software. And OpenDSS software is a comprehensive electrical power system simulation tool primarily used for electrical utilities and power distribution systems. And to start, the team received a code of the load profile of Ball State University. And below, I have attached what that load profile looks like before we've touched it. So it shows every 15 minutes what the load profile for our section of the campus has. So after we design our solar design in Aurora software, we can look and see how many kilowatts we are generating, and we can throw that into the code and kind of see how our load profile changes from there. And that's kind of the next step for me, is as the design gets made, I need to be able to add the lines of code to create the OpenDSS software, what it's supposed to be. And yeah.
Hello, my name's Anastasia Muir, and I'm an electrical engineering major focusing on electrical power and energy systems. I'm working on the development plan for our Solar District Cup entry. The development plan is composed of three main parts: the jurisdictional land use plans and regulations, which come from the authority having jurisdiction, which in this case is the city of Muncie, Indiana. There are also environmental, historical, and cultural site constraints, which come from other U.S. government resources, and the landowner or district master plan, which in this case will come from Ball State University themselves. The jurisdictional land use plans and regulations, we will use zoning maps to ensure that the areas are zoned correctly, or if they will need to be rezoned, to find out if we need special or conditional use permitting, or if there are other forms required. We're also going to look into transportation plans, environmental conservation areas, comprehensive site plans, and satellite maps to see what other obstacles will impact the construction of the solar panels. We're going to look into environmental, historical, and cultural site constraints using USGS current and historical topographical maps to see what the land looks like, what slopes there are. We're going to look at USDA web soil surveys to see what soil conditions we're dealing with, if it's acidic, if it's soft, if it's particularly hard, because that will impact the construction costs. We're also going to use U.S. Fish and Wildlife Service critical habitat mappers and wetland mappers to see if we're going to impact the environment or if it will impact us. We will also look at FEMA flood maps, because being in a flood zone will greatly impact cost of our construction. The insurance will be higher, as well as we'll have to build stronger, sturdier structures to hold the solar panels. We also have to look into the National Register of Historic Places. We actually have the Westwood Historic District right across the street from the section of campus that we are working to put solar panels on, and that could be it could be a problem or not, depending on if the people of the historical area have a problem with the visual aspect of the solar panels. We're also going to look into the Ball State University master plan, because that will impact our work as well. Primarily, they're looking to build a new athletic complex across the street from where we're putting the solar panel field, which could impact if there's shadows, if there's going to be any sort of power draw. They're also looking long range to renovate and partially rebuild the Neuer complex. So it's possible that we're not going to want to put solar panels there in the event that they're going to just have to take them down in the next few years to rebuild the area. So we're going to use all of this information to build our development plan, which will then be used to finalize our conceptual system design and to build the financial model.
Hello, hi, this is Delano Dunbar. I'm going to be doing the financial analysis and performance modeling for our solar design project. This particular process is going to be broken down into 4 critical pieces. First, identifying the PV system cost inputs and sources, identifying the financial performance inputs and their sources, and then finally going into the cash flows over the 20-year PPA term and putting that into our final proposal for the offered PPA to the district and justification. There's going to be 3 different tools and resources I want to point out as I'm going through this particular presentation. That's going to be the NREL PV System Cost Benchmarks, which is a public document which gives us prices and financing information for renewable energies. I also want to point out the NREL Cost of Renewable Energy spreadsheet tool, a very robust template that allows us to input data and be able to get visual information back in very different ways. And finally, the Aurora solar pricing and financing analysis has proven to be very helpful, and being able to identify and input some of this information for a single location and being able to get a return back. Now, for this first particular piece of the financial analysis, the first step is probably identifying the PV system cost, what we need to consider, the price of the panels, the price of the inverters. Is it going to be a one-axis tracker? Is it going to be a fixed tilt? So the solar system cost benchmark provides general information regarding some of these decisions. On the image to the left here, you can see that it gives us a span from 2010 to 2018 with different information as far as installed costs, annual degradation, operation and maintenance, pre-inverters, inflation, just to name a few. And we can kind of see how those values and those financing numbers have changed over the years. To the image just to the right of that previous figure, you'll see a table that's identifying residential and commercial type cost, some of the drivers of the cost, which increase the cost and decrease the cost. So these are things that we definitely need to consider, we definitely need to discuss as we're coming through and developing our design for Ball State University. Understanding how our decisions are going to affect the overall cost and financing of our project. Now, once we've been able to make some of these decisions on what solar panel we're going to use, what's the price of the inverter, is it going to be a fixed or a track type of system, we can input this information into the Aurora design software. You can see here within the figure, it gives us options to identify the project life, utility bill savings or tax, degradation, just some of that information that we were able to look up from the benchmark document. Ultimately, by putting this information in Aurora, we're able to kind of get some analysis, and it'll run an analysis either by the cash, which is default financing, or the power purchase agreement, which is just a default one input by the Aurora software company. And they were able to identify lifetime savings, year 1 monthly payments, PPA escalation rate, and get detailed analysis on the decisions or the values that we've input for our configuration. I found this very helpful and a really good place to begin my work in such a large scope. Ultimately, what we'll be able to pull out is a annual projected cash flow, the returns, and all these other metrics for the information we've collected. Again, when doing this, we need to consider renewable energy tax credits and solar renewable energy credits. And a lot of this information I've been able to find on the Indiana state government site. And on this particular screen, just to the right, is selected PPA content. Some of the information that you'll see in our final PPA is going to be very detailed, and we'll have to really kind of make sure we have our ducks in a row when it comes to that piece. Finally, I think this project is going to really challenge us to work all the different skills that we've learned, whether it's soft skills, whether it's technical skills, getting out of our comfort zone to understand some of these different phases or some of these different options that, we might not be as familiar with or confident with. So I'm really proud of the team so far. I think we're on a road to be able to produce everything we need for our first deliverable, and hopefully we can come up with a great design at the end of this thing.